Hello everyone, welcome back to the course on Learn to Read Architectural and Structural Drawings with ETABS. In this lecture, we'll try to see how the plinth beam layout has been worked out and we'll try to understand them. So this is the plinth beam layout, what you can see here. So I'll go back to that. So what they've written is it's a PB18, plinth beam 18. Um, and the size what you can see is 300 by 750. So everywhere it is PB18 here in this line. It is a 300 mm by 750 mm is the size of the plinth beam. So this was not even a size of our ground floor and a roof beam in the residential project, whereas here the plinth beam itself is 300 mm by 750. So just imagine the kind of a load that is coming on the beam. And I think everywhere it is a 300 by 750. Yeah, so everywhere it is a 300 by 750 mm of the size of the plinth beam. So this much is my plinth area, only this much is my plinth area. So you can see a plinth beam given everywhere, and here they have written yeah, so it's again you have a PB18, PB17. So everywhere it is a plinth beam what they are given. Even in this inner two, they wanted to connect it to the plinth beam. That is why they have written PB20, 300 mm by 750. These two beams, these two pedestal what we have, they have to be connected with the beam, and these two also have to be connected with the beam. Similarly, this two and this two has to be connected with the beam. So this is a kind of plinth beam framing what they have done. Yeah. Now coming to what is the reinforcement details that we need to provide, since we have only two, that is PB18, PB19 and PB20. So it's very simple. V into W into D is given, that is width and depth, what it means that. So it is 300 by 750 everywhere. Now coming to the reinforcement. So this is a different way of writing the reinforcement. What they have done is they have considered a single beam, but what they have done is they have taken the left hand here, they are writing it as midspan and they are giving it as right hand. Right, they are not shown a cross section, they are not shown a longitudinal section. If you can remember, in the residential buildings what we had, that given us the cross section as well, right? This was a kind of a cross section that we got. Then that given, they were giving a bar something like this, they were giving a bar something like this, and they were writing it as 3 of 16 dia. Then they were writing and giving an extra bar here, right? And they were giving extra bar here. So those things are not shown here. Mm, what this structure consultant has done is they are writing it in terms of left hand, middle span and the right hand. So in the left span you have to provide 20 diameter 5 bar, middle span you have to provide 20 diameter 3 bar, and right hand you have to provide 20 diameter 5 bar at the top. And in the bottom what you have to do is 20 diameter 3 bar in the bottom, 20 diameter 6 bar in the bottom, and 20 diameter 3 bar in the bottom. So how do we understand these things? It's again a simple thing. What I'll try to draw a beam here. So this is a beam I'm trying to draw. Yeah. So how do we do this now? So now I'll try to make this into three zones, that is left, right, and center, so that it is easy for us to understand. So I'll tell this is my left hand, okay, and this is my right hand, and this is my middle span. So what I can see here, in the left hand you have to provide a 20 diameter 5 bar, that is fine. Even in the right side I have to provide 20 diameter 5 bar at the top, I mean the top portion, that is also good. In the mid span it has to be 20 diameter 3 bar. But what you have to observe one thing is, you can see 5 bar, but what has happened, 1 2 3 bar is in the top, and in the second layer you are providing 2 bar here, right? All that counts to 5. Similarly, you are providing 1 2 3 bar at the top, and in the second layer you are providing 1 and 2 bar. Adding 3 plus 2 comes out to be 5. But whereas in the middle span, only in the upper zone you have, I mean in the first layer you have 3 bars of 20 diameter. That means you have to run 20 diameter 3 bar throughout. You have to see 3 bar is here also, 3 bar also here, 3 bar here. That means in the top what I'm going to do, I'll run my 1 bar come straight. So this will be my 20 diameter 3 bar. So now that condition is satisfied. Now coming to the second layer, near the left you have to provide 20 diameter 2 bar in the bottom. Again on the right side you have to provide 20 diameter 2 bar in the bottom. So what I'll do, I'll provide another bar something like this. This is my second layer, and also I'll provide another bar. This is my second layer. So this will be my 2 of 20, and this also will be my 2 of 20, right? So whatever we are doing right now, it's the same thing what we have been seeing in the residential building, where they had given a longitudinal section, but they are not giving a longitudinal section. We engineers should be good enough to understand or interpret what the structure consultant is trying to tell us. Now coming to the bottom portion, you have to provide 20 diameter 3 bar in the left. On the right, you have to provide 20 diameter 3 bar. And in the middle, you have to provide 20 diameter 6 number of the bar. But whereas in the bottom, you can see in the first layer in the bottom, 1, 2, 3, 1, 2, 3, and 1, 2, 3. So what I'm going to do, I'll make use of a different color so that we can differentiate it easily. So I'll provide, this is my, which number of bar? 20 diameter 3 bar I'll provide in the lower region, 20 diameter 3 bar. Now that is satisfied. This condition is satisfied here. 3 I have given on the left side. Again, 3 on the right side. That is also satisfied. Now in the center, I need to give another 3 bar, right? In the first layer, all 3 are satisfied. Now I have to provide another 20 diameter 3 bar in the second layer. So what I'm going to do, only in the center portion, this is my center portion. So in the middle span, you are getting only a 20 diameter 3 bar in the second layer. So what I'm going to do, I'm going to provide one more bar in this way. This will be my 20 diameter 3 bar again, right? Yeah. So this is how we have to give the reinforcement. Now whatever the curtailment length and all, that remains the same. That will be usually given in one of the general drawings. In the general drawing, they are going to give throughout the project, this is the drawing we need to refer, and based on that, the curtailment length has to be given. Like we saw it in the residential project, they're not going to give each and every cross section, and then they're going to give the curtailment length. So here what they do is they give one general drawing. We'll try to see that general drawing as well, so that maybe in the next lecture we'll take up that. Yeah, I don't have the general drawing here. Anyhow, we'll take up that general drawing in the next lecture. So now what has happened? This curtailment length, we know that it is 0.25 times the L1. This is also 0.25 times the L1. And this will be 0.15 times the L1. We have to leave this and we have to do the curtailment. And this also, it has to be 0.15 times into L1 and we have to do the curtailment. If you understood, it's well and good. Else we are going to take up one lecture where we'll try to understand the general drawings. So this is how the reinforcement is to be provided. Now coming to the stirrup, again it's the same thing. Here we guys are a bit lucky here, because the consultant has given us the counted a number of stirrups and given. He's telling us that you have to make use of 8 bar. It has to be a two-legged only, but you have to provide 15 number of bars at 100 spacing from the left end. Here you have to provide 15 number of stirrups at 100 spacing in the left side. Here you have to, on the right side, you have to provide 15 number of bar of 8 two legged at 100 center to center spacing. Here also I'm going to provide 15 stirrups. I'm going to provide 15 stirrups at 100 center to center spacing. Whereas in the center, you have to provide 150 center to center spacing. So here he has not given the number, but once you start to place at 150, you're going automatically, that will set and you're going to get the number of stirrups, right? So yeah, so I'll try to erase this part, right? You're able to understand. See, this 15 is for the left support, this is the middle one, and this is a right side one. This is how we have to provide. So what is the reason behind this? One is a shear reinforcement that is coming. Second is that we need to, since it is a earth, this building is falling in the earthquake zone, we need to refer IS 13920, and based on the earthquake detailing clause, we need to detail it in this way. That is why you can see the stirrups given in this way. And we know the reason, because here stirrup force is maximum, so we try to increase the spacing. That is, we are clear with that. So this is how we try. Only one thing what we can appreciate the structure consultant is that he has given us how many number of rings has to be given, so that as a site engineer I don't have to calculate this. Otherwise I should have calculated this by dividing this beam span divided by 3, and then I had to do the calculation. But here we are a bit lucky that we are directly getting number of stirrups to be provided here, right? So this is how we need to provide the reinforcement for the plinth beam. So we'll try to discard it. Other than that, it's the same thing everywhere. There is no much changes. Yeah, there's no changes. Again, here also it is same thing. Only thing, maybe the reinforcement might change. Yeah, here you are providing a 20 diameter, here you are providing a 16 diameter. Same thing everywhere, it's a 16 diameter. This things remains the same. Again, for PB20 also it's the same thing. So in PB20, I think very less load is coming. That is why you're not providing any extra bar. 20 diameter 3 in the top is sufficient, 20 diameter 3 in the bottom is sufficient, and 8 bar two leg at 15 at 100 center to center spacing near the support, and 150 at the span is sufficient enough to take care of the load. So this is how the plinth beam has been worked out. and this is how we need to understand them. Yeah, so we'll see you back in the next lecture. Thank you.